Okay, so let's just for fun, since we have this on the board, let's say we found that it was this one, whose side lengths were both integers. Okay, so we found a pentagon whose sides 5 longs plus 3 mediums was an integer, and whose diagonals 8 longs plus 5 mediums was an integer. Okay, so what does that mean? Does it mean the longs and the mediums both have to be integers?
Well,
no,
longs.
but the longs are integers. We can say that they are.
The longs are.
Well, they don't have to be integers.
Right, they don't have to be. If this is the first one we found, if this is the first one with the side 5 long plus 3 medium and the diagonal is 8 long plus 5 medium, we don't know that even that the longs and mediums are integers all by themselves, but we know 5 longs plus 3 mediums is an integer and 8 longs plus 5 mediums is an integer. So what do you think? What do you think the descent argument is?
Well, we would have to find one that was smaller than it.
Okay, and had what property?
And they were still integers.
They were still integers, okay. So what do you think we do?
Well, you could... How would you set up some sort of ratio that would help you with this? Or do you even set up a ratio?
How can I find a smaller pentagon now, whose diagonals are integers and whose sides are integers, once I know I have this one?
Well, you can take the pentagon that you have. Well, you can create a pentagram inside it.
Okay, yeah. We can create a pentagram inside of it. So what is the, can you circle the pentagon side and diagonal for the one that's inside of this one?
So
Where is it?
it's up here.
Okay, it's that one.
The marker ran out.
Our marker. You had the right idea. You had the right thing to circle, but the marker suddenly sort of lost its juice. Okay, so it's that one. All right. So how can I understand the side lengths of the side and diagonal for this pentagon that was inside the other one from these two?
We can look at the diagonals
Okay.
of the big pentagon.
All right.
And we know those are integers.
We know this is an integer. Yep. This one here.
Yeah.
We know that's an integer.
And the diagonals, they aren't the sides of our smaller pentagon. But
No, it's not. But I do know this side is an integer too.
yeah.
So how do I go from my big pentagon to the small pentagon?
So, what could you use?
It's the next Fibonacci number down.
Oh, it's the next Fibonacci number down. So how do I
So-
go, how did I go this way?
So you
How did I go this way?
You added.
You added these two.
Okay. So how do I go
So you
back the other way?
subtract.
What do I subtract?
Subtract.
You're subtracting integer values, though.
But what am I subtracting and what am I
You're
getting?
subtracting 5 minus 3 equals 2.
And then
Okay.
minus 5 is 3.
Okay, so the difference between the diagonal and the side of the big pentagon is equal to what?
Is equal to
The
the diagonal of our small pentagon.
Of the diagonal of the small pentagon. Okay? But this was an integer and this was an integer.
So you're subtracting and you get an integer.
So I'm subtracting and I get an integer. Okay, so my diagonal, I thought this was the smallest one, but I found one whose diagonal was an integer.
But then you can use these two to get the side being an integer.
So this is an integer.
Aha!
And then you can just keep going down and
Integer.
down and down.
Uh-huh. So it's really a very similar argument. It was easy and very natural to go this way. And you guys found the Fibonacci numbers going this way.
You just go back down.
Now you just go back down, you subtract. Integer minus integer is integer. So the diagonal minus the side is the smaller diagonal. And now the side minus the smaller diagonal is the smaller side. So there you go. So if I found the smallest one that were both integers, what happens next?
Subtract.
You
Integer.
get a
Subtract.
smaller one.
I found the smaller one.
Integer.
So they can never be integers.
Have to be non-integers.
So now that we've just proved they can never be integers, you are on the right track. If you say the longs have length 1,
mediums can't be integers.
mediums are not an integer. And if you say the mediums have length 1, the longs are not an integer.
Whew. Pretty complicated proof.
Pretty complicated, but pretty neat too.
Yeah.
Little geometry, little algebra. High five, guys. Good work.